Welcome to Math 335. Let's try some questions that are similar to exam questions. Number 1. The weight of an organ in adult males has a bell-shaped distribution with mean of 300 grams and standard deviation of 50 grams. Use the empirical rule or the normal rule to determine the following. Now we have a nice picture of the normal rule here, and we're going to use this to solve this question. Now, before I even look at the questions, I want to find the mean and the standard deviation. If you read the question very carefully, it is given that the mean is equal to 300. So we know mu equals 300, and we know that the standard deviation is 50 grams. So I'm going to put sigma equals 50 grams. Now we're going to use this information to fill in the normal rule. Now let's put the mean, which is 300, right in the middle. Mu is 300, and I need to add 50 to get to the next section. So let's add 50 to 300. That gives us 350. Add 50 again to get to the next section. That's 400. Add 50 one more time to get to this very edge. That's 450. On the left side, we're going to subtract our standard deviation. 300 minus 50 is 250. Subtract 50 again, I get 200. Subtract 50 again, I get 150. Now this is going to allow us to answer the questions that's coming up. So let's look at the questions. Part A, about 68% of organs will be between what weights? 68%. So that's a golden number that we have to look up, and it's right here, 68%. So I know if my weights are between 250 and 350, that's going to capture 68% of those weights. So let's enter our answer as 250 grams to 350 grams. We know that the weights between 250 grams to 350 grams is going to capture 68% of the weights. Part B. What percent of organs weigh between 150 grams and 450 grams? So we'll look up 150 grams, that's this number here. And 450 grams, that's this number here. So we can add all of these areas in from 150 all the way to 450. But that's going to take a lot of effort. That's going to take a lot of time. If you look carefully, the work is already done for us. At the top of the chart, they're adding from this section all the way to this section, which is what we want, and that's 99.7%. So we know the answer is 99.7%. 99.7% of organs are going to be between 150 to 450 grams. Part C. What weights of organs weigh less than 150 grams or more than 450 grams? So what we're going to look for is organs that weigh less than 150 grams. This is 150, but we say less than. So we're just going to get this little tiny area here to the left of it. That's what we want. And then we want more than 450 grams. That's going to be to the right side. So we want this tiny little area here. So the easiest way to do it would be to add 0.15 plus another 0.15. So we'll add that, 0.15 plus 0.15, and that gives us 0.3%. So I know 0.3% of organs are going to weigh less than 150 grams or more than 450 grams. Now this is not the only way to do it. We can also look at the picture again and do it a different way. Notice that essentially the area underneath this figure is going to represent 100%. So I could have also done 100% minus the things on the inside that I don't want, which is 99.7%. And if you were to do that, you get the same answer, 0.3%. So don't think there's only one way to do it. You can also do subtraction from 100% because that's the area of the whole figure minus the area that we don't want, 99.7%. So there's more than one way to do these types of problems. Part D, what percent of organs weigh between 150 grams and 400 grams? Notice in the question they said between 150 grams and 400 grams. So we want to find the area between the two numbers. So we want to be between 150 and 400. So now we could do it a couple different ways again. I could add the areas. This area, this area, this area, all the way up to here, and then we'll find our answer. So we could add 2.35%, 13.5%, 34, 34, and then 13.5%, and I guarantee you, you will get the right answer. However, we can look at it more carefully and do it a little bit faster. So notice that we want the entire area between these numbers. Now I know that if I look at this section from here to this section here, the addition is already done for me. I know from here to here it's 95%. So I can take 95% and add 2.35%, and I will get my answer a lot faster. So we have 95% plus 2.35%, and if we add this up, that's 97.35%. That is our solution. So there's more than one way to do it, but we still get the same answer. Question 2. The average 20 to 29-year-old man is 69.6 inches tall with a standard deviation of 3.0 inches, while the average 20 to 29-year-old woman is 64.1 inches tall with a standard deviation of 3.8 inches. Who is relatively taller, a 75-inch man or a 70-inch woman, and why? To do this question, we're going to use z-scores. Z-score is equivalent to x minus mu divided by sigma. Now mu is the mean, sigma is our standard deviation, and x is our actual value for the man or the woman. So let's do two sides of this equation and we'll see who is relatively taller. For the men, we have the average height is 69.6 inches tall. So that's mu. And their standard deviation is 3.0. While a woman has an average height of 64.1 inches. So for the woman, we have the mean is 64.1. And their standard deviation is 3.8 inches. Now for our value, we have the man here is 75 inches tall, so that's x. And for the woman, we have this woman is 70 inches tall, so x is 70 for the woman. So on one side I have men, and on the other side we have the woman. Now let's use the formula for z-score. We have z equals 75 minus 69.6 divided by 3.0. And this gives us a z-score of 1.8. Now notice this number is greater than 0. Remember, a z-score of 0 implies that you are average. Now this person has a z-score of 1.8, which means they are 1.8 standard deviations above average height for men. This person is 1.8 standard deviations above average for a man. On this side we have z equals 70 minus 64.1 divided by 3.8. Z is equal to approximately 1.55. Again, this score is above 0, so this woman is above average height also. But now we have to answer the question, who is relatively taller? Well, in this case, we can see that 1.8 is larger than 1.55. This implies the man is taller, relatively speaking, because he is 1.8 standard deviations above average, while the woman is only 1.55 standard deviations above average.